So we left off actually Friday talking about hail and getting into thunderstorms. Did anybody get hail over the weekend? Nobody got hail. My parents said they got a lot of hail in Maypearl. Uh, Said it hailed for basically an hour. So yeah, some of the Metroplex did get some hail over the weekend with the storms that moved through. I guess there is a possibility for hail also tonight around 6 p.m. So be aware of that. We left off Friday talking about hail and the updrafts. The updrafts are what's needed for hail. If there were no updrafts, you wouldn't really get hail bigger than just your regular rain size frozen pieces. It's the updrafts that pushes the hail further up into the rain cloud and allows it to gather more water around it and freeze and become bigger and bigger and bigger. And so when you have larger pieces of hail, that's a good sign that you have quite a few updrafts, kind of recycling those inside the cloud and allowing them to get bigger and bigger and bigger. Let's see. They got a couple of pictures of hail here, so you can see the concentric circle around it and just how it's kind of built up layer after layer after layer. If you're up close, you can even see some smaller rings inside here. And so they just kind of build up like a snowman or like an onion. You just got to add layer to layer on top of the core, and it just gets bigger and bigger and bigger. Then they got into tornadoes, which we're a little bit more familiar with here in Texas. We are at the southern end of Tornado Alley, as that takes place every spring. So we're getting into tornado season right now. Usually spawned by severe thunderstorms. We look for the supercell events that have a lot of circular motion in them. The rotation is going to be what spawns off your tornadoes inside. And there are a variety of shapes of tornadoes. In general, we're less concerned about the shape and more concerned about the damage and how long they stay on the ground. But they have little skinny ones called rope tornadoes. The funnel tornado is probably the classic one that we're used to. It's the tornado you see on the news all the time, the ones in the pictures. Cylinder is going to be your really, really large tornadoes, I believe. The ones that are so wide and take up so much space that you kind of lose that funnel shape, and it's just one big squat cylinder. And then you have some wedge tornadoes, which are probably a little bit less common. So they're saying that the tornado is defined by the vortex extending downward from the cloud and touching the ground. And we kind of know that here in Texas. It's not a technical tornado until it touches the ground. If it's just a funnel cloud up in the sky and it never has a touchdown, then it wasn't a tornado. It was just a funnel cloud. So once it touches the ground, then we have a confirmed tornado, and we can kind of begin trying to define how large and how bad that tornado was. Formed where there are large differences in atmospheric pressure over short distances. You also get that rotation happening as that pressure difference kind of tries to even out, and that rotation is what spins up your tornado. So organizational stage, basically what you hear the weather people talking about all the time when we have these dangerous storms is the vertical wind shear. You've got a lot of air masses moving up and down. This is going to cause your rotation. So vertical wind shear causes your rotation to develop within the storm. These strong updrafts in advance of the front tilt the horizontally rotating air vertical. This is known as a mesocyclone. And so updrafts near the storm, lower part of the cloud, which is called the cloud wall, and the wall rotates and lowers down until it touches the ground, and now you have a tornado on the ground. So that's the organizational stage. It going from vertical wind shears, the wind shears kind of rotating down and becoming horizontal, and then updrafts kind of feeding that storm and bringing the wall cloud down, and then the wall cloud rotating down until it touches the ground, and now you have a tornado. So they're showing you a little bit of a funnel cloud before it touches the ground, and then this is like your wall cloud. So this is the part you can see it's descended down out of the main cloud and the storms. And if this has any rotation going on in there, you would see a tornado kind of organize out of the wall cloud and come down and touch down. So number 2 is the mature stage. This is where your tornado has already formed. So visible condensation funnel extends to the ground, so you see the funnel all the way down to the ground. Your moist air is drawn upward. That's what's feeding the tornado. So inside the funnel, you have air coming upward through the funnel. In stronger tornadoes, smaller whirls may develop within a tornado. So on the inside, you can actually have multiple little tornadoes kind of inside. They call these suction vortices, and they're responsible for the greatest damage if you have a tornado that has those inside. Then you have another stage, the shrinking stage, where your tornado starts to dissipate. The supply of warm air that's feeding it is reduced. It starts to starve the tornado. This is more dangerous because your wind speeds increase as your diameter decreases. So for this part, think of figure skaters. We all watch figure skating, right? I don't know why, but when it's on the TV, you see the figure skating, and you're like, okay, I'll stop and watch this. And they do the spinny part, right? And then when they spin, if they hold their legs out and their arms out, they're spinning kind of slow. And then they pull their legs and arms in, and they get spinning like really fast. So when you bring your rotational speed inward, it allows you to spin much, much faster. If you throw your arms and legs out wide, you're going to spin slower. And so that's the same thing with the tornado. When the tornado is big and wide, in order to get the same wind speeds, it's got to go really fast around that huge area. When it kind of dissipates, you would think it's going to get weaker, and it does get weaker. But because it actually gets thinner, the winds pick up speed. That rotational wind kind of centralizes in a smaller space and allows it to actually go faster. And so for the small area that's around this tiny, thin tornado, you're going to have really high speeds there. And then it gets down to the rope stage. Downdrafts cause the tornado to move erratically and disappear, and it just kind of burns itself out. So while it's doing its thing and becoming a big tornado, you're looking at the updrafts are feeding it energy. At the last stage, just before it falls apart, you get the downdrafts, and that kind of undoes all of the organization in the cloud and the tornado. So let's see, classifications of tornadoes. We have an EF scale, an enhanced Fujita scale. This is how we measure our tornadoes. It's from 1 to 5. And so let's see. They talk about water spouts a little bit. Here we go. Here's the 1 through 5 Fujita scale. And basically an EF, well, I guess it's 0 through 5. An EF0 is a tornado that technically touched down but did very little damage. Very low wind speeds, 105 to 137 kilometers per hour, which is only 65 to 85 miles per hour. Not a lot. Very light damage. Some damage to chimneys, tree branches, shallow-rooted trees might be pushed over, or some signs. But other than that, not a lot of damage. Versus all the way down at EF5, your wind speeds are 322 kilometers per hour, which is more than 200 miles per hour, and you have an incredible amount of damage. Strong frame houses have been leveled off of foundations and swept away. Automobile-sized missiles fly through the air in excess of 100 miles per hour. That means they're picking up cars. This tornado is picking up cars and throwing them around at high speeds. Not only have trees been knocked down and thrown around, but they've had the bark ripped off. Incredible phenomenon will occur, so you'll see weird things like 2x4s blasted through trees and different stuff like that. And so when they talk about F scale, if you see a tornado on the news, they will estimate this first. But you can see, based on the damage here and the wind speed, they actually have to go in and survey the damage and try to calculate exactly what the wind speed was in certain localities before they can finalize what F scale they think it was. Let's see, occurrence for tornadoes. Found throughout the world, but much more common in the United States. And you can have tornadoes in most places in the United States. They just don't happen that often. But we've heard of tornadoes happening in very rare places. Has just the right combination of weather, topography, and geographic location. And they're really talking about Tornado Alley here. So most U.S. tornadoes occur in the Midwestern states between the Rocky Mountains and the Appalachians. That's Tornado Alley. Spring and summer in late afternoon and evening are the most common times. So we're in springtime right now, and I don't think it has tornado chances, but we do have a hailstorm coming in late afternoon, early evening time today. And so that is pretty common. Very rarely do we have a 10 o'clock in the morning tornado. Usually it's in the evening after everybody's got home and it's starting to get dark, or it's already gotten dark. Highest risk is in our beloved Tornado Alley, which stretches north to south through the Great Plains states. Several tornado-prone areas are in Canada as well, include Alberta, southern Ontario, and the southeastern Quebec. Water spouts are tornadoes that take place over water and basically only involve water. So here's your Tornado Alley, which we are a part of for sure. Texas has quite a bit of area that's at risk for tornadoes. I think right here in your red spot, you're talking Oklahoma, Kansas area. The good news about that is there's just not a lot of stuff going on. There are some towns and some bigger cities, but they're not that big. And the vast majority of this area right here is just a bunch of empty farmland. And so we do have a lot of tornadoes there. I think the vast majority of them don't do a lot of damage to human life. They do a lot of property damage and personal damage, but don't kill tens or hundreds of people. So that's kind of a good thing. But yeah, you can see that most of the United States have some sort of tornadoes. Florida actually has a higher number than I would have guessed, but you hear about tornadoes happening in Florida all the time, and you can even get some up here in the Northeast. It's not unheard of. So let's keep going. Water spouts. Here's a picture of a water spout. Little tiny thin tornadoes that form over water instead of land. I think they can be pretty dangerous for boats and other seagoing people and vessels. But in general, they're not going to cause as much problems as like a normal tornado. Now we get to blizzards and ice storms. We don't deal with blizzards too often down here. And we don't deal with blizzards at all down here. Even when we get ice storms and we call them blizzards, they're not blizzards. So a blizzard is a severe winter storm with large amounts of falling or blowing snow, high winds, low visibility for extended periods of times, and really they're referring to days or weeks, not really hours. So whiteout conditions have extremely low visibility where it's just snowing so much you can't really see. Official thresholds differ. In the United States, we're looking at certain thresholds here, 35 mile per hour winds for at least 3 hours with low visibilities. In Canada, they're looking at 25 miles per hour winds for at least 4 hours, so lower and longer for Canada. And then you have a ground blizzard. If your wind or your snow has already fallen, but it's not packed, it's just kind of sitting on the ground, your high winds can pick up that snow and move it around. And so you can have a blizzard even when it's really not snowing if it's windy right after it has snowed. What causes blizzards? Interaction between upper level low pressure trough and low surface area. Basically, you need some really cold air to pick up a lot of moisture. Because cold air in general isn't going to be very good at holding moisture. So it's got to pick it up somewhere really soon after it drops it off, or before it drops off, sorry. So Colorado and coastal storms derived from moist ocean air. So the big blizzards they get in Colorado, that air was just picked up from the Pacific usually. Alberta clippers are drier with less snow and cold temperatures. Nor'easters on the East Coast have hurricane force winds, heavy snows, and intense precipitation and high waves. So basically, if you're talking Colorado blizzards, they get their moisture from the Pacific Ocean. If you're talking the western part of Canada, it's going to be the same thing, Pacific Ocean. In the central part of the country, generally they will get moisture from the Great Lakes. And so if a cold air mass goes over the Great Lakes, it can pick up a lot of moisture and drop snow on the other side. And then in the Northeast, they have it both ways. They can get their moisture from the Great Lakes or from the Atlantic. and so they get quite a bit of snow up in the Northeast. Wind chills. Wind cools the skin, evaporates moisture, reduces time it takes for frostbite to form. A reason blizzards are generally more dangerous than other snowstorms is because of that wind chill. And so we're a little familiar with the wind chill here. We don't worry about it too much when it gets cold because it doesn't get like deadly cold down here too often. But the wind chill does help us out in the summer because if it's 106 and there's no wind, then it's just like 106 and maybe 110 with the heat index. But the wind's blowing like a nice 20, 25 degrees or 25 miles per hour. It can make it feel a little bit cooler outside and help everybody survive the hot Texas summers. So what do we have? These are different tracks for your storms to drop blizzards. I'm sorry, I just instantly forgot the word. Your storms to drop blizzards in different parts of the United States. So they're showing the Alberta Clipper coming down through Canada, and it's going to pick up its moisture from the Great Lakes and probably drop a blizzard right on the other side over here. The Northern Pacific one can bring some moisture from the Pacific itself and drop some blizzards up here in the northern areas, just on the other side of the Rockies. The Colorado one's probably going to do something similar, bringing moisture down here to have a blizzard in Colorado and the Denver area. And then this one's not really going to bring snow. It's going to pick up moisture all along here down into the Gulf of Mexico, and it's going to bring that moisture north along the coastline here, and that's going to add to blizzard conditions up in the Northeast once it gets back into colder temperatures. So there's several different ways you can get that moisture into the cold areas or bring the cold air down to the moisture where you can kind of form a blizzard. So ice storms versus blizzards. Ice storms are going to have more freezing rain versus snow. So prolonged periods of freezing rain. Upon contact with cold objects, the rain immediately freezes to form a coating of ice. Developed during winter on the north side of a stationary warm front. These are really bad because ice is heavy. When these happen, ice builds up on the power lines, knocks out a lot of power. It builds up on the road. People can't drive. These ice storms really shut down a city whenever they hit for quite a while. It's a lot to deal with, and generally we can't do that as well. So 3 conditions for freezing rain. I got to have a lot of moisture. I have to have warm air over a shallow layer of cold air. And what I need my rain to be liquid while it's falling. If it's ice while it's falling, it's going to come down as hail. And hail's bad enough on its own, but it's not going to freeze on everything. It's not going to stick to everything. I need it to come down while it's liquid and then freeze upon contact. That's going to allow it to build up that ice coating over everything. That's going to become a big problem. So objects on land close to or at freezing temperature, that's going to allow it to freeze on top of it. So what are they showing us here? They're showing us the type of freezing weather that we get. If we don't really have any warm air in the mix, it's just cold air with moisture in it. It's just going to be a regular snow, a light, fluffy snow that you can sled in. You can build snowmen. If I have a little bit of warm air over top, but it's mostly cold air in my air package, then I'm going to get some sleet. As my rain falls, it's going to freeze before it hits the ground, and I'm going to have sleet. Depending on the updrafts, maybe some hail. Here, I've got a little bit more warm air. It's going to freeze just before it hits the ground, or maybe after it hits the ground, and I'm going to have freezing rain. And then here, I don't have enough cold air at all to freeze anything, and so this is just regular rain. So this is like your progression from rain to snow, depending on how much warm air versus cold air you have. Fog. They actually spend a lot of time talking about fog. I don't remember if it's this PowerPoint. I'm going to go through this quickly because we don't get a lot of fog in Texas. And in general, there's very specific parts of the country that deal with this a lot, and then the rest of us really don't. So if you live in San Francisco, if you live in Chicago or near the Great Lakes, you probably deal with fog a lot. Here in Texas, not so much, and it's usually gone by like 7, 8 o'clock in the morning. Like as soon as the sun comes up, the fog's usually gone. But let's go through it. So fog is a cloud in contact with the ground. It's literally like low clouds. They don't always start up high and come low. In general, in Texas, when we have foggy days, that is what's happening. They're higher up clouds that have been pushed down by some air package and are now too close to the ground, and they're blocking up our vision. Other fog that they're going to probably talk about more is clouds forming close to the ground due to moisture and temperature changes. So they form by air cooling or to condensing or adding water to cooled air through evaporation. So if you're cooling down air at night, heat radiates from the land, warm air blows over the cold water, humid air rises up a mountainside. These are three different ways you can cool stuff down and get fog overnight. Evaporation, your cold air flows over a warm body of water. This happens quite a bit at the Great Lakes. Kind of the late summertime into fall, your Great Lakes have been warm all year because of the summer sun. So you have these big warm bodies of water, the Great Lakes, and then you get cold air coming in from Canada, blowing down from like the tundra of Canada. It comes over the lakes, picks up all this water that's evaporated, and as soon as it gets to the other side of the lake, it's just fog. It's just like fog everywhere. So warm rain falls through cold air. That can also help your evaporation and kind of give you a foggy effect. So they don't talk about fog very long. Then they move on to drought. Drought is an extended period of low precipitation. Texas is almost like perpetually in drought. Our lakes are always low, and there's always at least a moderate drought going on, if not a severe drought. In fact, like for most of my life, we were just always so much in a drought. They were like, this is below normal rain conditions for Texas. And it's like, if it's 10 years in a row, shouldn't you just change your expected rain conditions and be like, oh, this is our new normal. We're not in a drought anymore. I don't know. There's an argument to be made there. So produces a shortage of water for people, animals, and plants in drought regions. Regional food shortages, because obviously you need water to grow food. Affects more people than any other natural hazard. Causes losses of $46 to $8 billion each year. I think this is probably what, 46 million to $8 billion dollars each year, maybe. Causes water and power shortages and agricultural problems. Droughts cause a lot of issues. While we're always in drought stage, Texas isn't affected by it too much. We have a lot of lakes, and we're kind of spread out as far as population density goes. And so while we're always in drought, very rarely does Texas make you ration water, where they're like, you can't water your lawns on these days, or you can't wash a car outside. If you've lived in California or followed the news, California seems to have that the most frequently. They have very dense population of people. They do have a lot of lakes, but probably not as many as they need. And so California always has some sort of water shortage going on, where you can't water your lawn, you can't wash your car outside, and there's heavy restrictions on water usage. So just kind of keep that in mind. It's nice when you don't have to worry about it, and then when you do, it can kind of become a big hassle. So North American drought conditions and effects. So you can see Texas, what do they have here? Abnormally dry, drought moderate. So right now on this map, when they made this, I assume, what is this? What color is this? The base color in the back. Is that just like nothing?
Yes.
So that's like a no color. All right. Well, we're abnormally dry here in the North Texas region. Wow, who'd have known? Northern Louisiana, severe drought, exceptional drought going on. When this map was made in 2015, so it's going to change every year. But who would have thought? Main island of Hawaii, exceptionally dry drought. I would have figured they get rain there all the time, and there's no drought at all. But I guess at least when this map was made, they were having some rain issues on the main island of Hawaii. So let's see, they get into mountain windstorms. We're not going to talk a lot about these. I will introduce one of the greatest words. Chinooks is a mountain windstorm. So these are storms east of the Rockies. What happens is the mountains block the prevailing winds and can, under specific conditions, cause winds to move quickly down slopes. They bring with them, usually I think the Chinooks bring these really cold air and can cause a lot of problems. So with the Chinooks, we have the Santa Anas, which happen in Southern California. They can cause roof and tree damage, blow cars off highways, and contribute to large wildfires. And so these are just these kind of out of the way, kind of sporadic winds that happen there. The Chinooks and the Santa Anas. Then they talk about dust storms. I mentioned dust storms the other day because I've got some family that lives in Arizona, so they get dust storms pretty frequently. Strong windstorms, which dust reduces visibility for a significant amount of time, can be several hundred kilometers in diameter and carry 100 million tons of dust. Safety hazard for travel, affect climate and human health. They're kind of a big deal. In general, unless you get caught out with one, it's probably not super dangerous on like a life or death scale. But they can cause a lot of property damage and mess up your day for sure. Sandstorms, desert phenomenon where sand is transported in a cloud, rarely extends above 2 meters above the land, and so it's a very low cloud. Along with dust storms, they occur mostly in the mid-latitude, semi-arid, and arid regions that you're going to find your deserts in. So here's an example of a dust storm. This is an old one. This is definitely like Depression era dust storm. But then this is going to be a more modern one. So you can see the high rises and just the huge dust cloud kind of coming in. So pretty interesting. Heat waves. I want to see how far away we are from the end. Let's see. 71 and 92. I think we can do it. Heat waves, prolonged periods of extreme heat that are both longer and hotter than normal. So a Texas summer doesn't count as a heat wave because it's just normal here. It's not any longer or hotter than it was last year. Associated with long areas of high pressure called ridges, wet conditions to the west of the ridge, dry conditions to the east of the ridge. And if you're in that east of the ridge area, you're probably going to be experiencing a little bit of extra heat. That high pressure system always sits over Texas in the summer, bringing us that summer weather we get. Accompanied by severe humidity or extreme dryness, important to monitor the heat index because it can feel a lot hotter than it actually is. Your body's perception of the air temperature is very important. So what they have here, your air temperature versus your relative humidity, and how much in danger you are because of that. So like here in Texas, let's say our air temperature is like 102. That's standard. That's not too bad for a normal summer day. If your relative humidity is low, if we got low humidity around 40%, so notice they don't even go too low on this. 40% is low they go. But our relative humidity is low, that's not too bad. We're in the middle orange here. We're in danger of a sunstroke, muscle cramps, and or heat exhaustion is likely. But if you drink your water and you do all the things that you're supposed to do, take plenty of breaks, stay in the shade when possible, you should be able to work a full 8-hour day and survive. But if you kick this up to like 55 or 60 degree or percent relative humidity, now the moisture in the air is going to help transmit that heat quite a bit. It's going to keep your body from releasing heat as much, and it's going to allow your body to kind of succumb to the heat much, much quicker. And so you pump up that humidity just a little bit, 40 to like 55, 60% humidity, and now you're in extreme danger. Heat stroke or sunstroke is highly likely. You just can't be outside for very long doing any kind of strenuous activity. Notice at 102 degrees, unless you have extremely low relative humidity, it's just not really safe for you to be outside in general. There is some sort of danger of you overheating. Now, anybody who's worked outside in Texas in the summer knows that that's a little bit of an exaggeration. There's like hundreds of thousands of people in this metroplex who work outside all day, every day, including 102-degree heat. That being said, you got to wear the proper clothing. You got to drink plenty of fluids. You got to take breaks, or you're probably not going to feel too great the next day. So let's see, human interaction with weather. They're going to go through a couple different topics. We usually talk about land use in some way or another, how we choose to do things in different areas, and that affects us because of the weather. So plowing cropland and leaving topsoil exposed can contribute to dust storms. Location of mobile homes, areas subject to frequent high winds and tornado increases damages and loss of life. And this is actually kind of important that not a lot of people talk about. The location of mobile home parks is generally in lower lying areas. Because in general, we allow mobile home parks to be built in floodplains where we will not allow permanent structures to be built in floodplains. One of the examples, I know y'all don't live there, but one of the examples is in Waxahachie, over by... It's over kind of by Bear Creek Road. Y'all know where the QT is in Waxahachie off the highway. So behind the QT is like the Life School, and there's like a Whataburger and a Sonic there. That Whataburger and Sonic right across the street from that, kind of right across the street from the new Atwoods. They just built a mobile home park. It's almost not even like a mobile home park. It's like a travel trailer RV park. Yeah. And everybody like on Nextdoor, because that's what Nextdoor is just people complaining about things. Everybody was complaining about the RV park when they were building it. They were like, we don't want that here. This is and the reasonable people got on and they were like, look, that's floodplain land. You literally can't build anything there other than maybe like an RV park or like a car wash or something. You're not going to be able to put like a permanent building there. No one's going to insure it. You can't get the permitting. And so, but one of the things that, this is a long rambling story and now I've gotten to the point. One of the things that tornadoes will do frequently is follow the valleys in different reliefs. Tornadoes very rarely follow along ridge lines in high elevation areas. They tend to stick to lower elevation areas. And so that's why like you almost get this feeling like tornadoes are out to get mobile home parks and stuff like that, because when a tornado hits, even if it hits a regular neighborhood, there's almost always a mobile home park that gets hit. And I think that has some sort of correlation to the low elevation. It's just where we tend to put mobile home parks is areas where tornadoes naturally are kind of funneled towards, and that's a bad combination. So notice they're not giving any advice on how to put mobile homes in a better location. They're just kind of pointing it out that they do get hit a lot, and it's probably because of the specific locations we end up putting them. Urban heat island effect. You'll see this on the news if you watch the news very frequently. The city always stays warmer, and that's because of all the concrete and all the buildings. They soak up the heat during the day, and at night they release that heat. And so the outlying areas will get down colder overnight, where the city kind of stays a little bit warmer and doesn't get those super cold temperatures overnight. Global warming can increase heat index and heat waves, intensity of precipitation, risk of drought, intensities of hurricanes, typhoons, and other tropical storms. And even if it's just a little bit, it can make a huge amount of effect. Here is the heat island kind of profile. It's just showing you that over city areas and urban areas that have lots of cement and lots of buildings, it's going to trap that heat in, and your temperature is generally going to stay warmer during most of the day, especially overnight. Overnight is where you see that heat island the most. Let's see, short-term events. Flooding, a slow-moving thunderstorm or some sort of release of water can cause flooding. What is this, mass movements? I don't know what they're talking about, mass movements here. Maybe like landslides, but like mass wasting kind of things. Wildfires can start from lightning strikes. that is a fairly frequent thing in areas that have wildfires as they get started by lightning strikes sometimes. Long-term challenges in global climate. We want to look at drought, dust and sandstorms, and heat waves. Tropical and extratropical cyclones are also short-term events. These are what bring us our general daily weather. Contribute to health of forests. So what are some natural service functions of severe weather? They're actually getting into wildfires a little bit. But your severe weather, the lightning can cause a wildfire. Wildfires are actually very good for the forest. They clear old growth. Windstorms can topple dead trees and weak trees and kind of make a little bit of extra space for the forest. And obviously, the rain helps the forest out as well. It's a good source of water. Blizzards and other snowstorms and thunderstorms and tropical storms are a primary source for some areas of water, especially areas that rely a lot on surface streams and rivers and lakes. Those are what's going to fill up your surface streams and rivers quite a bit. Aesthetic value, obviously, clouds and snow and lightning are a nice bit of scenery for the right type of person. I enjoy stormy days and thunderstorms and rain and all that stuff. I'd much rather have a cloudy day than like a 106-degree Texas summer day. And then tourism. Tornado chasing is actually a big thing in tourism. Different other severe storms. Obviously, there's going to be a big tourism boost after a big blizzard in places that have snow and other skiing and outdoor winter sports kind of things. Minimizing severe weather hazards. Severe weather will continue to threaten human lives and property. There's not a lot you can do. You can't change the weather. We can barely predict the weather a week or two ahead. We're certainly not anywhere close to changing the weather. As long as people live in the path of hazards, we must take steps to minimize the damage and loss of life. Predicting the events accurately will help reduce the hazard. Timely and accurate prediction is extremely important to spare human lives. And we know about that here in Texas. You don't have a lot of time to protect yourself from a tornado. It's been a long, difficult road to the point where we're at now, where a lot of cities have tornado sirens. Does Palmer have tornado sirens? You think so? Do they test them every once in a while? I've never heard them here, so I don't know. But it's tough, because even the towns that have tornado sirens, there's a lot of places in the town that you can't hear them. I lived in an apartment complex in Waxahachie for a while, and we were actually pretty close to one of the tornado sirens, but we were on the other side of the apartment complex, and we were close to the highway. And so the highway always drowned out the tornado siren. And it went off several times when we were supposed to hear it, and we couldn't hear it at all. We happened to be watching the weather, so we knew about it. But it's pretty important being able to warn people in a timely manner. So Doppler radar has significantly improved the ability to predict paths of storms and what's going on. Good morning. Oh, I guess the bell. Why didn't y'all tell me the bell had rang? Jeez. She tried very hard. No, she's like, All right. So that's mostly it. We might have a couple slides left, but we'll finish this off.